Once processing is complete, we'll save our composition as AC 3.1 processed, stabilization testing. Saving each iteration of your composition while processing your data can be helpful if you ever need to refer to steps you've previously taken. Let's take a look at the results of processing the stages. The first thing we can see is that the textures are broken on all non-keyframe frames. This is because the underlying mesh and UV layout of these frames have changed, but the textures have not yet been updated. We will correct the textures in a later stage of the process called texture transfer. We can see that segment brackets have appeared on our intervals. Segment brackets are the light gray brackets at the bottom of the interval display. These show what ranges of frames have been grouped together into segments. Because we are working on a small frame range for testing, it's possible that some of the segments may span the entire length of our intervals. An individual segment can't be any longer than the stabilized interval it was created in, but longer intervals can contain multiple individual segments. The other change to note is the presence of keyframe markers, the small diamond indicators present on frames 25, 99, 104, and so on. The keyframe marker indicates where on the interval a keyframe is located. There will be one of these indicators for every segment. Stabilization changes the topology of each non-keyframe mesh, so their old textures no longer correspond to the mesh. To correct this, HoloEdit provides a texture transfer stage to manually recreate the textures. We'll walk through that process later in the tutorial. For now, we'll remove the load asset stage containing our texture data. Since all of the previous stages have only affected our mesh data, removing this load asset stage will not affect those results. We'll ensure that the light is toggled on to view our mesh with normals. Let's review the quality of the results. To do this, we'll compare the load asset stage to the stabilization stage using the comparison view display mode. The comparison view becomes available when you have two stages selected at the same time in the track view panel. First, we'll select the load asset stage in the composition window, then Control-click to add the stabilization stage to the selection. In the top left-hand corner of the viewport, next to the transform tools, a comparison button should appear. Press the comparison button to enable comparison view. The first stage that you clicked will be highlighted in the track editor with a red indicator, and the second with a blue indicator. In split view modes, we can see which stage is represented in the views by looking at the bottom outside quarters. There are three ways to inspect your data using comparison view. Split view. The split view mode displays the results of the two stages divided by a line in the viewport. On the left or red side of the line will be the first stage you selected, and on the right or the blue side will be the second stage selection. You can click on the handle on the line and drag it left or right to reveal more or less of either view to compare the both stages from the same camera view. Heat map. The heat map view shows the second stage you selected, the blue one, with a surface heat map indicating the level of difference between it and the first stage. The heat map allows for quick visual confirmation of the accuracy of surfaces, running from blue to green to red. There are two modes in heat map view, relative and absolute. Relative, which interpolates the error to values present on the mesh. The greatest error present on a given frame will always be red, and the least will always be blue. Absolute scales the gradient between the provided error min and max error values, where the heat map is scaled from blue at the error min to green to red at the error max. And side by side. Side by side splits the screen in half and shows both selected stages on screen at the same time from the same camera view. Let's inspect our results with the heat map view. We'll leave the mode in absolute and change the segment max error to 0.025. Narrow the frame range for playback by selecting the interval and pressing Ctrl-L. Hit play and rotate around your actor to review the heat map. Blue areas are perfect matches. Green areas are a little less exact, and red areas exceed the max error we specified. On green and red areas, we'll want to take a closer look to make sure that the variances between the stabilized mesh and load asset don't affect the results of our texture transfer stage down the line. If there's a lot of green and red in the heat map, you may want to try some different values for stabilization. Switching between the different comparison view modes is a quick way to find what settings worked well and what settings need finer tuning. The first interval, from frame 25 to 44, looks pretty good. The mask has some flaws. It doesn't quite follow the motion from the load asset stage, and there's a bit of jitter. Also, since there's only one segment, there's an issue with the hair, where it doesn't quite match the surface of the source after frame 27. Smaller segments could help with this problem, instead of using a keyframe where the hair topology is disconnected from the shoulder for the entire segment. Moving on to the second interval, from frames 95 to 114. The shape and the gesture of the hand looks good in playback. A glaring issue is the snapping of the right sleeve as she draws her hand back between frames 107 and 108. If you compare the stabilized mesh to the load asset using the split view, we can see the severity of the discrepancy clearly. If we take a closer look at the hand in the beginning of the interval, we can also see some issues with the position of the hand and the length of the fingers. In frame 95, from the side, you can see that the fingers are quite long and don't sit at the correct angle. Something else that's important to be aware of are their small, rigid objects that could be improperly deformed by the non-rigid deformation process. So making sure you take time to check things like the flute and gun prop hanging out of her belt is important. Using scrubbing through the interval, you can see that there is quite a bit of added wobble in the tips of the props. The third interval is a bit worse. The first thing that stands out is the pop of the right sleeve between frames 203 and 204. Moving to the end of the interval, you can see that both frames 217 and 218 deformed poorly. To try and diagnose some of the problems with this segment, let's take a look at the keyframe, frame 212. There's a lot of noise and undesirable mesh detail in the crook of the arm. With this frame chosen as the keyframe for the third interval in all three of our segments, it's unlikely that we'll be able to get a satisfactory result from this segment. Let's move on to reviewing our second stage. In the first interval, looks pretty good overall. The first interval is okay, but has some areas that aren't quite satisfactory. Because it's front and center in the performance, we want to make sure that the stabilization of the mask is precise. We can see that the shape of the mask doesn't properly carry through this interval. Looking over the rest of the interval, the shapes of the sleeves is pretty good. There are similar issues with the hair here as with the first stage. The second interval has results that are quite similar to the first stage. The shape and gesture of the hand look quite good in playback, but there are issues with snaps on the sleeves and with the shape and length of the fingers throughout. Additionally, the props in her costume still wobble significantly. Let's take a look at the third interval for this stage. The third interval has an okay result with a few artifacts. From frame 204 to 205, we can see some pretty dramatic snaps in the sleeves. The shape of the poses throughout the interval aren't too bad, but if you compare the left sleeve towards the end of the segment that includes frames 208 to 217, you can see the bottom of the sleeve loses its length and sharpness of the corner. Let's take a quick review of the third stage. With a quick look, we can see that the results are worse than the other two stages. The movement is a bit stiffer, and the snaps between the segments are more pronounced. We don't need to take the time to go over this closely, as we know that we have more favorable results in the other stages. We know that some of the settings we used gave us some pretty good results overall, but they weren't quite satisfactory. For this next step, we'll tweak those to see if we can get a better result and rerun the tests. One of the options we can look at is enabling Keyframe. Keyframe works by using the result of each previous deformation as the source frame for the next one. This can result in smoother deformation, with more consistent motion over larger segments, such as the segment with the mask losing its shape and jittering. This is an experimental feature in HoloEdit 2020.3 and may not be appropriate for all stabilization needs, but it's a powerful tool that's worth trying out for this capture. Additionally, we're going to take a look at adjusting the alpha point and segment max error. Alpha point will bring down to 0.05. We'll set the alpha rigid to 125, alpha smooth to 200, the match distance limit at 0.05, and the segment max error to 0.065. You'll also notice as we change the parameters for the stage that has already been processed, a yellow bar will appear on the affected intervals, indicating that the data is dirty and needs to be rerun to reflect the current settings of the interval. For the second stage, we'll use all of the same settings, but enable Keyframe. Alpha point will bring down to 0.05, we'll set the alpha rigid to 125. We'll enable Keyframe, alpha smooth to 200, the match distance at 0.05, we'll change the segment max error to 0.045, and the sample radius factor to 10. For the third stage, we'll bring the alpha point down to 0.03. We'll set the alpha rigid to 125, we'll enable Keyframe, the alpha smooth to 200, we'll set the match distance limit to 0.05, and set the segment max error to 0.052, and the sample radius factor to 10. We'll clear the data from the stabilized stages. Let's save this composition as AC 3.2 Stabilization Testing. Execute the stages, and compare the results in the next video.